Similar triangles and the Pythagorean Theorem, Chapter Q. The sum of the interior angles of a plane triangle is 180 degrees. If we name the triangle with capital letters at the vertices, capital A, B, and C. If we assume that angle B is 60 degrees and angle A is 45 degrees, then angle C is equal to 180 degrees minus the sum of 45 degrees and 60 degrees. That is a geometric fact regarding plane triangles. An acute angled triangle is one in which all of the angles are less than 90 degrees. An obtuse angled triangle one angle of the triangle is larger than 90 degrees. Less than 180 degrees. A right-angled triangle. This is a triangle where one of the angles equals 90 degrees exactly. In this example, we'll put a square box in this corner of the triangle to emphasize that that is equal to 90 degrees. Call this A, B, C. It is common practice when we deal with triangles, if we use capital letters A, B, C as the names of the vertices of the triangle, we then use small letters A, B, C to represent the length of sides opposite these angles in a corresponding fashion. In other words, this side, because it's opposite A, will be called small a, and that represents this length. This then is small b, and this then is small c. The length c, which is opposite the right angle, is referred to as the hypotenuse. In similar triangles, for two triangles to be similar, all angles of one triangle must be correspondingly equal to the angles of the other. Notice that because of the interior angle sum property of triangles, only two corresponding angles need be determined equal. The third angles are automatically equal. This can be interpreted to mean, then, that for similar triangles, it means that triangles are the same shape, but not the same size. For example, we'll assume that this angle, we'll call it O, is the same size as this angle, also call it O. And this angle, call it X, is equal to this angle, also call it X. As I have explained, once two corresponding angles of the triangles are equal, the third angles are automatically equal by the interior angle sum fact. So this angle Y is equal to this angle Y. As you can see, they are the same shape, but they are not the same size. And these are referred to as similar triangles. Let's call this triangle A, B, C. And this triangle D, E, F. We can write this fact in symbols in the following way. Triangle A, B, C is similar, three vertical lines, to triangle D, E, F. Let's name the lengths of sides of each triangle. This will be referred to as A then, this one as B, and this one as C. This will be small d, E, and F. Under the given circumstances, for similar triangles, the ratio of corresponding sides, which are the sides opposite the corresponding equal angles, these ratios are found equal. In other words, A is to D, corresponding sides create a ratio, A over D, is equal to B over E, which in turn is equal to C over f. By the alternation property of proportions, we can derive several other kinds of proportions from this example. That is also true. For example, the ratio of b over a must equal e over d. The ratio c over b is equal to the ratio f over e. The ratio c over a is equal to the ratio f over d. These last three proportions that I have written can be reciprocated. In other words, a over b is equal to d over e, b over c is equal to e over f, and a over c is equal to d over f by the inverse property of proportions. Continuing with the Pythagorean theorem, the square on the hypotenuse is equal to the sum of the squares on the other two sides. Constructing a right-angled triangle with this equal to the right angle, and naming the triangle ABC with sides small a, small b, and small c.